After azeotropic mixture, we have got the topics called as colligative properties, which is a very important properties of a very dilute solution. And these properties are very important as we deal with the numericals. So colligative properties means the properties of very dilute solution which depend upon the number of particles of solute in solution, but not upon the nature of the solid particles in solutions. They are called as colligative properties. So the colligative properties depends on only on the number of particles. They do not depend on the nature of the solid particles. And basically there are four colligative properties. First one is relative lowering of vapor pressure. Second, elevation in boiling point. Third one, depression in freezing point. And the fourth one, we have got osmotic pressure. We have to see one by one along with the definition, expression and the numerical based on it. So the first one we are going to see is relative lowering of vapor pressure. As we know that the vapor pressure of a volatile solvent gets lowered after the addition of non-volatile solute to it. This we have seen in the Raoult's law definition as well. So if P naught is the vapor pressure of pure solvent and PS represents the vapor pressure of the solution, and we know that the vapor pressure of the solution gets lowered after adding non-volatile solute. So the lowering of vapor pressure will be vapor pressure of pure solvent minus vapor pressure of the solution, and relative lowering of vapor pressure will be given by P naught minus PS by P naught. So according to Raoult's law, we have got this expression, that is relative lowering of vapor pressure is equal to the mole fraction of the solute. This expression we have got from the Raoult's law. Now we'll derive the expression from which we'll calculate the molecular mass of solute from lowering of vapor pressure. So as we know from Raoult's law, we have got this expression P naught minus PS by P naught equals to X solute, and P naught minus PS by P naught. So for mole fraction of the solute we can write as N. Small n is the number of moles of solute and capital N is the number of moles of solvent. So N by N plus capital N. Now this one further we can just replace that small n by W by M, because number of moles will be equal to weight in gram by molecular weight. This is the formula. So we just change it by W by M. Now if the solution is very dilute, that is less than 5%, the approximate value formula is used. In such cases n, small n plus capital N will be equal to capital N, because when the number of moles of solute is very small, so we can ignore it, and so it will be equal to capital N. So the expression changes to small n by Wn. Now we'll just put the value for we'll put the expression small n equals to weight in gram by molecular weight, and this also number of moles of solvent also weight by molecular weight. So this is the final expression that we can see, and after that the each letters have got a significant meaning. We can see small w is weight of solute in gram, capital W is weight of solvent in gram, small m molecular mass of solute, and capital M molecular mass of solvent. Now in our next class we'll be seeing the numerical based on these past ISC questions.